Predicting trigonal bipyramidal shape. In this example problem, it says, what are the bonding angles for ClF3 as predicted by the VSEPR theory? So what we have to first notice is this has 3 bonds and 2 lone pairs. So as we can see for ClF3, it has 2 lone pairs, this 1, 2, and bonds, 1, 2, and 3 bonds. This tells me that it's actually not a trigonal bipyramidal shape. It is part of that same family with 5 things that go around it, like 5 atoms that could potentially go around it. But it is actually a T shape. It's actually a T shape. So if I look at this, this looks like a T. If I drew a big line here and a big line here, it looks like a T. So this is a T shape, what I call a T shape, but it has 3 bonds and 2 lone pairs and could potentially form what would be a trigonal bipyramidal shape. So, according to the VSEPR model, it does have different bond angles based on the lone pairs that it has, because we count it for the atoms of space between the angles between the atoms, not necessarily between the lone pairs. So here, there is a 90-degree angle. As we can see, a right angle is formed, so A is one of our answers. And the degree between here is 180 degrees. And the degree between here is 90 degrees. So we can see that 90 and 80 degrees are the 180 degrees are the answer to this problem. If we did have a trigonal bipyramidal shape, if we had five atoms that were bonded here, we would include 120 degrees, but that is not included here because we only have 3 bonds and 2 lone pairs forming a T shape.